Good evening, everyone. Good evening, friends. Welcome back to our sessions on Python for AI. So, in the last session, we started understanding data pre-processing, right? The last class, we have understood two steps under data pre-processing. Okay. So, data pre-processing is nothing but we are actually cleaning the data. What are we doing? We are cleaning the data. So, under this data pre-processing, we have 9 steps. What are the 9 steps that we have under data pre-processing? Typecasting, then handling duplicates, outlier treatment or outlier analysis, zero near zero variance, discretization or binning or grouping, encoding, handling missing values, transformations, and finally feature scaling or feature shrinking. So these are the 9 steps that we have under data pre-processing or data cleansing, or also called as data munging. We can also call it as data organizing or data wrangling. Okay. All these mean same. Okay. If you are actually going through any of the job descriptions related to data related roles, you will find one of the skill that is data cleansing. So where you have to know all these 9 steps. Okay. So all these sessions are very important, guys, especially from yesterday, whatever we have started understanding the data pre-processing steps, till we complete these 9 steps, each and every session is important. We understood typecasting and handling duplicates, right? Yes. So what exactly is typecasting? Typecasting is nothing but type conversion. Conversion of one data type to other. Which function we use under typecasting? As type is the function that we use for conversion of data type. Then handling duplicates. What is a duplicate? Duplicate is nothing but the same row getting repeated. Okay. Where the values of the rows should be same in the same columns. Right. Yes. And how did we handle duplicates? In order to identify duplicates, we use duplicated function. But in order to handle the duplicates, in order to remove it, we use drop underscore duplicates function. Right. So we also, I started explaining the documentations. Documentations, you have to go through each and every documentation. For all the functions, the key functions from these packages, you will find documentations. Even for read underscore Excel also, there is a documentation. But the problem is we generally go through it. We don't go through it. If you go through each and every documentation, you can understand the function well, the functionality of each and every function, and you can utilize it in a better way. So, documentations play a crucial role. Right. So, keep is the parameter which takes 3 different values, first, last, and false. We understood. Right? Yes. And later on, we started understanding outlier analysis, outlier treatment, treating the outliers. Right? Yes. So we are supposed to continue with outlier analysis. And we have also understood that the only plot which gives us outliers, which visualizes outliers, is box plot. Box plot will return the information about the outliers. Okay. So when we visualize a box plot, we'll come to know the outliers, the presence of outliers in the column or not. We have done that, right? Anyways, we'll start again from the beginning of outlier treatment. Then we'll understand what techniques have to be implemented. What are the methods that we have to handle these outliers in real time? Okay, right. So I'm going to import the required packages. First of all, pandas. I'm importing pandas as PD. Pandas is for data manipulation, right? Yes. And I'm also giving an alias name as PD, universal standard. In the same way, I'm importing numpy as NP. This is for numpy is for calculating, for basic calculations. Next to numpy, we are also importing matplotlib.pyplot. For visualizations, we go with pyplot. There is a module called pyplot in matplotlib, okay, which will have all the functionalities of related to visualizations. So I'm importing pyplot alone and I'm giving an alias name as PLT. Next to PLT, I mean next to pyplot, we are importing cborn as SNS. I'm importing cborn. Cborn is also a package for data visualization, but it is an advanced package. Compared to matplotlib, it is an advanced package. So I'm importing cborn as SNS. Done. So post importing the required packages, what am I doing? What am I doing? I'm going to read the data from an Excel file. Yes. So read underscore Excel is the function where I'm using it to read the data from an Excel file. Okay. Since the data is present in an Excel file, .xlsx. The format, if you see, of the file, it is xlsx. So I'm using read underscore Excel function to read the data from an Excel file, which is present inside pandas package. So that is the reason we are using pd.read underscore Excel. And the data will be stored in DF. Let me do it. The same data, cars data. So 428 rows and 14 columns. Good enough. Now, let me generate a box plot. I'm using plot function. Okay. So in order to handle the outliers, we should come to know whether there are outliers or not. If there are outliers, probably we have to handle them. If there are no outliers, what is the use of handling them? Right? So for that reason, we are visualizing a box plot. I am visualizing a box plot. So plot is the function. I'm taking the entire data frame df on which we are going to visualize a box plot. So the kind parameter takes box. So that means we are going to visualize a box plot. Fine. The figure size of this entire plot should be 12 by 8. Width is 12, height is 8. Subplots, yes, I would like to get the subplots. True. Next to it, we have Sherry. Sherry represents false, which means I don't want to have the y-axis shade. Done. And I'm also specifying the colors for box as blue. Whisker should be in orange. Medians, the Q2 should be in black. And the caps should be in red color. Patch artist means whether we would like to shade this entire box or not. Yes, the box has to be shaded with the color. True. Show flyers represent whether the outliers should be displayed or not. Yes, I want the outliers to be displayed. So I'm keeping it as true. So I'll execute all these lines together. Okay, before that, we also have a few more lines of code related to the plot. Okay, from matplotlib.pyplot from PLT, I'm using a function called subplots_adjust. This will adjust the subplots in which I'm using a parameter W space, which means width space between the subplots. It should be 0.8, probably inches, 0.8 inches. And the title of the plot will be box plot for all numerical columns. And I would like to display the plot, so I'm using show function. So when I execute all these lines together, let me see what will be the result. Anyways, we have visualized yesterday, right? We came to know that all the columns have outliers. All the columns have the extreme values. You observe each and every column has outliers. So what we are going to do? We are going to treat these outliers. We are going to treat the outliers. We know that the limits in the box plot are calculated with a formula. What it is? The formula says Q plus or minus 1.5 times of IQR. What is this formula used for? The formula is used for calculating the limits. See, this is the box plot. Yes. So this will be Q1 and this will be Q2. This part will be Q3. So towards the Q1, we'll have a limit that is called lower limit. And towards Q3, we'll have one more boundary, a limit called upper limit. Okay, IQR is calculated as the interquartile range. That means the complete box. IQR is given with Q3 minus Q1. IQR is calculated as Q3 minus Q1. Then, what is the formula for lower limit? Lower limit takes the same formula in which Q will be replaced as Q1 minus 1.5 times of IQR. Then, upper limit will be calculated as Q3 plus 1.5 times of IQR. 1.5 times of IQR. So, by using this formula, we can get the limits calculated. And once if the limits gets calculated, we can understand the outliers. So that means if the values are less than lower limit or if the values are greater than upper limit, then we say that values are outliers, extreme values. So what am I doing? I am going to take one of the column that is MPG underscore city. We know that MPG underscore city have outliers. Yes. I am taking this column and I'll calculate these limits. Okay. So before calculating limits, I should have IQR. And before calculating IQR, I should have Q3 and Q1 calculated. 25th percentile and 75th percentile has to be calculated. So what will I do? Initially, I'll calculate Q1. In order to calculate percentiles, there is a function called quantile. There is a function called quantile. Since I am calculating Q1 of what? Q1 of MPG city, I should pass only the values of that specific column. So how can I access one specific column from a data frame? There are two approaches. One is data frame object dot column. This is approach 1. And the approach 2 says data frame object dot no of column. So representing the data in square braces. This is approach 2. I am following approach 2. I am following approach 2. So this will return me the column of MPG city. By taking the values of MPG city, how many values I'll have? 428 values. How come? See, each and every column contains 428 values. So these values will be used to calculate the 25th percentile. So 25th percentile is nothing but passing 0.25 to the quantile function. By using these values, 25th percentile value will be calculated. In the same way, can I also calculate Q3? Yes, what is Q3? Q3 represents 75th percentile, my friends. Q1 is 25th percentile, Q2 is 50th percentile, and Q3 represents 75th percentile. So use the same line of code and change the value. Instead of 0.25, we'll keep it as 0.75. This will return me Q3. Yes. So I calculated Q1 and Q3. Can I get IQR calculated? Yes. It is nothing but the difference between Q3 and Q1. I can calculate IQR. So once after having all these three, all the three components, Q1, Q3 and IQR, I can calculate lower limit and upper limit. How? I'll use these formulas. I'll use the formula of Q1 minus 1.5 times of IQR and Q3 plus 1.5 times of IQR to calculate lower limit and upper limit respectively. Okay, I hope it's making sense. Let me execute all these steps together or one by one. So this will calculate me Q1. What is Q1? 17.0. And the next line will calculate Q3, 21.25. And the next line will calculate IQR. It is 4.25. Are we done? Yes. Let us substitute these values. The operators is what we are using. Okay, I just use subtraction operator, multiplication operator, and addition operator. So let me do it. Lower limit calculated and upper limit is also calculated. So these are the values. You see the values? Yes. Now, one thing that I have to do is, I am supposed to handle outliers. The extreme values, the outliers that are present in this MPG underscore city column have to be handled. I can use techniques like RRR. RRR. Okay. So the first R represents recognize. Recognizing the outliers. So what we are doing? We are identifying the outliers. How can you identify the outlier? We have a logic. What does the logic says? The logic says, just try to understand guys. Within the column, what column it is? MPG city. Okay. Within the column, the values of MPG city, if they are less than lower bound, or identical, this is called vertical pipe. It's representing OR operator, right? Yes. So if the values are less than lower limit, or if the values are greater than upper limit, what are they called? They are called outliers. Yes. So those kind of records should be fetched from the data frame DF. How am I accessing the values, the outliers? We know that outliers are nothing but the values which are less than lower limit, or the values which are greater than upper limit are nothing but outliers. So those kind of, if the condition is matching for any of the record, those records from the data frame has to be fetched and they have to be written to, they have to save to an object called outliers, a variable called outliers. Let me do it. Yes, it's done. Can you tell me the size of outliers? What is the size of outliers? How many outliers do you see, guys? Do you observe? Outliers is a data frame and the size is 30 by 14. What does it mean? How many outliers it means? It means there are 30 outliers. 30 by 14 represents 30 outliers are present in the data. Why? Why are ignoring 14? 14 is representing the columns, right? See. So, you see here, these are the 30 records which are outliers. Why are they outliers? First of all, you see in the MPG city column, in the MPG city column, if the values are less than lower limit or if they are greater than upper limit, they will be filtered. They will be filtered and they are stored to a separate data frame called outliers. So that means there are in total 30 outliers in this column. What is this column called? MPG city. There are 30 outliers. So how can I get that information? Is I'm going to print it first of all. The data frame that we have, I'm going to print to the console. Anyhow, I cannot understand it because it's an entire data frame, right? We cannot understand the output. In order to understand, in order to get the information of the number of outliers present in the data, I'm just going to get the shape of 0. Shape is an attribute. Shape is an attribute. What is outliers? Outliers is a data frame. Data frame. On a data frame, when we are using shape attribute, it returns dimensions. It returns the number of rows and the number of columns. But am I just using shape attribute? No. Within the shape attribute, I just want the dimension which is present at index 0. So which of these dimensions is present at index 0? Obviously rows. Column 1. Column will be at index 1. So shape of 0 will just return me the number of rows in the data frame. It will return me only the number of rows. I hope it's clear, guys. So this will return me what? 30. And this 30 gets stored in a variable called num underscore outliers. It gets stored in num underscore outliers. So this num underscore outliers, I am going to use in the next line of code where the formatting will be done, and this will return me number of outliers in MPG city colon 30. Formatting is getting done. String formatting. Right? So let me do it. Let me execute the results. So line number 142 will return me the output as 30. And for 143, the output will be number of outliers in MPG city is 30. Clear? So we identified that there are 30 outliers, but we have to, what is our goal? Our goal is to handle the outliers. So the next R that we have is remove, the remove technique. But when we remove the technique, when we use this remove technique, what happens? We'll have data loss. Am I right? What we are going to have? We'll have data loss, guys. Why there will be a data loss? Why there will be a data loss? Because whatever the outliers that were observed will get removed. That is what remove outliers means. Remove technique will remove the outliers from the data, which means 30 records from our original data frame, 428 records. From 428 records, 30 records will be removed. What is the logic that we are writing here? You see, the same logic. If the values in MPG city column, if they are greater than or equals to lower bound, so that means if the values under this MPG city column, okay, if they are greater than or equals to lower bound, and okay, end operator, and if the values in the MPG city, if they are less than or equals to upper bound, so that means all the original values, only those values has to be returned, has to be filtered from the data frame, from the original data frame, so that what gets removed? The 30 records, the outliers get removed, and the rest of the records, that means 398 records will be stored in data underscore cleaned object. Let me do it. So data underscore cleaned is a data frame of size 398 records and 14 columns. Why 398? 428 minus 30. 428 minus 30 is 398 rows. So what does this 398 rows means? That means the data is free of outliers. There are no outliers in these records. What am I going to do? I am going to print the clean data. This particular data frame I am going to print using print function. Anyhow, you'll not understand because you have 14 columns. We cannot interpret the output of this line. Fine. Now, why don't we visualize the box plot on the column MPG city present in this data frame? Because let us cross check, guys. Let us cross check. We have removed the outliers, right? In the previous step. Why don't we cross check by visualizing a box plot? If I visualize a box plot and then if I don't see any outlier, I can confirm that the outliers have been removed. But without visualizing a box plot, how can I confirm? That is one question that we have to ask ourselves. So for that reason, what am I doing? I am visualizing a box plot from, the box plot is from Seaborn, SNS. It means Seaborn. From Seaborn, I am going to visualize box plot. Okay. So I'm taking this entire data frame, but on which column I'm going to visualize box plot? MPG underscore city. On this column alone, I'm going to visualize box plot. Let me cross check. Yes. I don't see any outliers now. No extreme values are present in the visualization. Since I'm using box plot function from Seaborn, the box will be shaded by default with the color blue. And moreover, you will also observe that the box is bulged. The box in bulge shape. Clear? So it's done from our side. So that means we have successfully removed the outliers from MPG city column. This is using remove technique. But in real time, remove is the least preferred technique. Why? Because of having outliers in one column like MPG city, what happened? 30 records were being removed. So that means there is a data loss. No client or no one will accept data loss in real time. No one will accept data loss in real time. Then what we have to do? Remove technique is least preferred in real time. It is not preferred. To be honest, not preferred. Why? Since I am working on just 400 records, I got 30 outliers. What if I work on millions of records? Probably I'll also have thousands of outliers. Yes. So if I use remove technique, what is going to happen? The data loss is going to happen, which is not accepted in real time. No, it's not accepted. So remove technique is least preferred. Then what is accepted? We can go with replace, guys. Replace is the other technique that is accepted in real time. But what does replace means? Replace is nothing but we are replacing the outliers, the extreme values, with the lower and upper bound values. We are going to replace the values of outliers with lower and upper limit values. How can I do it? Again, the same logic. Let us understand this logic first of all. So, np dot where is a function. Np is what? Np is numpy. Am I right? Yes. So, within numpy, there is a function called where. There is a function called where. So, I'm going to use where function from numpy. Okay. Where it checks for the condition. What is the condition? If the values in the MPG city column, I'm taking the DF, means the original data, which contains outliers. Okay. Not the clean data, guys. Pay attention. If the values in this MPG city column, if they are greater than upper bound, okay, those values have to be replaced with upper bound values. I repeat, if this condition satisfies for any of the values present in MPG underscore city column, that means the values, if they are greater than upper bound, those values will be replaced with upper bound value. What is upper bound? 27.625. 27.625. Okay. And I'm using one more np.where function to keep the the condition again. Wherever the values are less than lower bound, the values are less than lower bound, they have to replace with lower bound values. So what you are doing here, you are replacing the values of the outliers with upper and lower bound values. What if the condition is not met? Assume that there is a value where this condition is not met and this condition is also not met. For such kind of cases, the value should be kept as it is. See. Okay. The first line is for the values which are greater than upper bound. They have to be replaced with upper bound values. The second line is for if the values are less than lower bound, they have to be replaced with lower bound values. And if the values under the MPG city columns, if it is not satisfying any of the condition, those values have to be taken as is. Those values will be taken as is. Since I am using NP numpy function, the output of this particular line will be an array. It will be an array. So this array I am converting back to data frame. How? Using a function data frame from pandas. That is why you have pd.dataframe initially. Inside data frame, you have all the conditions. Why? Because the output of this part is an array. This part alone will return as an array object, guys. Okay. So that is the reason we are not using an array object. I mean, we are not going to have the output in array. I'm converting back to data frame. I'm going to convert back to data frame. And this data frame, where it is going to store? In the original data frame, I'm going to create a new column with the name mpgcity_replaced. So, within this data frame, a new column will be added. So, what will be the size? 428, 15. The output will be 428, 15. So, let me do it. Done? Yes. You see, 14 became 15. That means a new column got added. What is a new column? MPG city_replaced. So this is the last column. I mean the recent column that got added when we perform replace technique. When we perform replace technique, the last column got added, guys. So you see here, obviously there are two values, okay, with the lower limit, lower bound, and many of them are having upper bound. See, many of the rows have upper bound values. They got replaced with the upper bound values. How many values in total? 30. How many values in total? 30. Now, I'm going to visualize a box plot on which column it is? The column that we have created just now, the same column it is. On the same column, on the same new column, I'm going to visualize a box plot. So let me do it. Do you observe any outliers in the visualization? Yes or no? Do you observe any outliers in the visualization? There are no outliers. No outliers in the data. So, either I can go with remove or I can go with replace. If not, I can go with one more technique called winsorization. There is one more technique called winsorization. What does winsorization does? Winsorization, first of all, it's a function coming from a package called feature_engine. What it is? It is a package called feature underscore engine. So friends, if you are trying to use winsorization, okay, if you have especially installed only Spider, you will not have feature engine in your local machine. You have to install it. How to install a package? How to install a package? We use tools like pip or conda to install the package. Right? Yes. So here I'm going to do what? From feature underscore engine dot outliers, I'm just importing the function called winsorizer. I'm importing the function called winsorizer. What is feature underscore engine? It is a package. What is outliers? Outliers represent a module. Okay, from this module, I'm using a function. I'm just importing a function alone. I'm importing a function alone. So friends, if you are using for the first time, probably you may not have the feature underscore engine package in your systems, in your local PCs, in your local machines. So you have to install it, guys. You have to install it. Right. So let us understand what is this feature underscore the function called winsorizer. So what am I doing? First of all, I am going to initialize winsorizer, the function called winsorizer. So in order to understand winsorizer, it's better if you go and read the documentation well. You see this? The first link, winsorizer. Just click on it. So this is the detailed documentation of winsorizer function. Feature underscore engine is our package. Okay. So within feature underscore engine, we have a module called outlier, and within it we have outliers in which we have the function as winsorizer. Okay. So what are the parameters that you see here? Capping method, tail, fold. Okay. Add indicators, variables, missing values, so on. So what is the purpose of winsorizer function? It winsorizer caps maximum and the minimum values of a variable at automatically determined values and optionally adds indicators. So adding indicators is optional. Okay. So when you don't want to add indicators, you can ignore. But what is the purpose of winsorizer is it is also performing, a kind of replacement only. It is performing replacement, but how? There are different methods. There are different capping methods. What are they? The first one is Gaussian approximation. It is Gaussian approximation. What is this Gaussian approximation? When we have understood the Z distribution, the normal distribution, that is called Gaussian distribution. That will be used under Gaussian approximation. If not, the method will be IQR. Whatever we are using traditionally, that is called IQR method. Q plus or minus 1.5 types of IQR. So that will be our IQR method. And we also have MAD. This is actually a median rule. And we also have percentiles. So depending on the method that we choose, the limits, the formula for the limits will change. If you take Gaussian as the method, what happens is the right tail, in order to calculate the right limit, okay, the upper limit, the formula will be mean plus 3 into standard deviation. That means mu plus 3 sigma. What about left tail? That means lower limit. The formula will be mu minus 3 sigma. So, I can understand that if I use Gaussian as the method, okay, if I don't specify also, it will take default value as Gaussian. Because if you see here, the default value for capping method is Gaussian. But what will be the formula for calculating the limits? It will be mu plus or minus 3 sigma. Mu plus or minus 3 sigma. What if I take IQR as the method, the capping method? The same formulas, Q3 plus or minus, Q3 plus 1.5 times of IQR and Q1 minus 1.5 times of IQR, the same, okay? If I take MAD as the method, okay? So it's a median absolute deviation. MAD stands for median absolute deviation from the median, from the middlemost value. What are the formulas? The formula will be median plus or minus 3.29 into MAD. MAD value. What if I take percentiles as the capping method? The right tail by default it takes 95th percentile and left tail takes 5th percentile. That's it. So what you can do it here? What you can understand here is when you can change these values. That means when you change these method, obviously, the formula gets changed. Not to calculate the limits, the formula is completely depending on the method that we use. But why do we have these many options? Let us understand that question first. Every time you cannot tell, for every data set, IQR method will fit well. You cannot tell every time Gaussian method will work well for this data. In order to treat the outliers, Gaussian method will work well or IQR method will work well. No one can tell this, guys. So what we do is we do experiments. We'll try with Gaussian and we'll check for box plot. If it is actually working well, then we'll continue. If Gaussian method is not fitting, we'll go with IQR. If IQR doesn't fit, we'll go with MAD. So in this way, we'll try with multiple experiments. We'll do multiple experiments. Okay, no one cannot tell by just looking at the data. Unless if you do an experiment, only then you can comment on the result. You can comment on the output. Okay, so let me go back. I hope this is clear. Capping method, IQR, and tail. I would like to treat the outliers at both the ends. So that is the reason I'm keeping it as both. If not, you can also specify at which end you want to treat the outliers. At which end you want to handle the outliers can be specified. Right, left, or both. So tail can take three options. Both, right, or left. And the third parameter that I'm going to have in Vinserizer is fold. In IQR, the value that we have for the fold is 1.5. What does this 1.5 says? In the formula of IQR method, what is the value that we have? 1.5, right? So that represents fold. That represents fold. Q plus or minus 1.5 times of IQR. The 1.5 that we have in the formula is actually representing fold. You can also adjust this fold. You can change it. You can increase, you can decrease. I'm going with the default one, and the variables that I'm going to have on which I'm going to use is MPG city on only one column. So initially, I'm going to initialize my function. Vinserizer function, I'm going to initialize. Okay. And this function post initializing, where am I going to store it? I'm going to store in a object, in a variable called Windsor underscore IQR. So let me initialize the function Vinserizer. It's done. It is done. Now, the function is present inside this object. Right. So what am I going to do? I'm going to use this function and I'll make it to fit on the data. For that, I'm using a function called fit underscore transform. What is the function that we are using, guys? I'll make this function Vinserizer, which got initialized earlier. I'll make it to fit on the data. And I also want the transformed results on the column. Okay. So this will return me initially Vinserizer gets fitted on the MPGCT column, and it will also return the transformed results. And these transformed results we are going to store where? In a new column under the same data frame DF, which have 15 columns. A new column will be created with MPG underscore city underscore IQR. So what will be the size? The size becomes 428 rows but 16 columns. The 16th column will be the transformed results of IQR. Capping method IQR. I hope it's clear. So let me execute this line. Done. If you see, it is 16 now. Let me open it. The last column, what do you see? MPG city underscore IQR. See, if you observe, it also performs similar to what? Replace. When you keep the same fold value, obviously, it performs the same like replace. See. Clear? Yes. Now, I'm going to visualize a box plot on. The data frame, the column IQR. The column that was being formed, that we have added earlier using IQR method. I'm going to visualize box plot on this column. So let me visualize the results. Any outliers were being observed? No outliers, guys. There are no outliers. So IQR method is working well for this data. That will be our conclusion. That will be the conclusion for this case, MPG underscore city. Let us also try with Gaussian. Let us also try with Gaussian. So what am I doing? I am initializing Vinserizer. I am changing the capping method to Gaussian. So when I keep the Gaussian as the capping method, what happens? What happens if I keep the Gaussian as the capping method? Yes, the limits, the formula gets changed. What is the formula? Mu plus or minus 3 sigma. So the tail will be both, fold will be 3, and which column it is? MPG city. So let me execute together. I'm initializing Vinserizer using Gaussian method and storing in a variable called Windsor underscore Gaussian. Windsor underscore Gaussian. This Windsor underscore Gaussian will be used on the original column where it gets fitted, and the transformed results will be obtained by using fit underscore transform function. Okay, the same object gets fitted on the data mpg underscore city, and it will also return me the transformed results. These transformed results will be stored back to again a new column. In the same data frame df, I'm going to create a new column with the name mpg city underscore GAU Gaussian. Let me do it. The size became 17. Now, on the last column, but do you think the results will be same? The output of IQR and the Gaussian, will it be same or different, guys? What do you do? What do you think? What do you say? Will the results be same or different? Obviously, it will be different. Why? You are changing the formula, right? When you are changing the method, what's happening? Obviously, the values are also getting changed. See, it is 10.625 in case of IQR, but in Gaussian, it is only 10. And the upper value, the maximum value that we have in the Gaussian is 35.757, but here it is just 27.625. Since the values, I mean the formula got changed, obviously the values will also change. Will not have the same values, right? Yes. Now I'm going to visualize box plot on the last column, the Gaussian results. Let us check whether the Gaussian will be a right method for the MPG city column or not. What do you see? What will be our conclusion? By looking at the box plot after applying the capping method as Gaussian. What is your take, guys? I see outliers still. I still see outliers. So what does it mean? So that means Gaussian is not a right method for MPG underscore city data. Okay. So even after applying Gaussian method, I still see outliers. What is the use? So no use. Let us continue to the next method. I'm just using the same code. I'm changing the values. That's it. I'm changing the value for the capping method. If you see here, this time I'm going to use the the capping method as quantiles. Quantiles. So it is nothing but percentile. So the tail will be both. At both the ends, we are going to, you know, treat the outliers, and the fold will be 0.05. Okay. So by default, the lower limit will be 5th percentile and the upper limit will be 95th percentile. And the variables that we are going to use are MPG city column. So let me initialize Winsorizer first of all. I'm done. I'm done. Now I'll use this variable, the object in which we have the Winsorizer. Okay. And I'll make it to fit on the data. And I'll also get the transformed results. These transformed results I'm going to store to the same data frame with a new column. It will create a new column. What will be the new column name? The new column name will be MPG underscore city underscore PER percentile. So let me do it, guys. 17 will become 18 now. 17 will become 18. So let me open it. You see here the last column. So 14 is the last, the base, the smallest value that is present in this column. And what is the maximum value? It is 29. It is 29. That is the maximum value. So what do you observe when you compare all these methods is you will not have the same results when you are changing the method. It might be IQR, Gaussian or percentiles or even MAD. Okay. So that is what you can interpret from here. Now, let me visualize the box plot on the new column that has been added, and let us also draw a conclusion accordingly. Oh, still I see outliers, guys. I still see outliers. Okay. So because of this, I can comment that my conclusion will be IQR is the best method for MPG city, compared to Gaussian, and what the method is? Percentiles method. Clear? So this is how we, do lot of experiments and we'll find the best one. Because no one cannot tell that this method works well for this data. No one on the planet, no one can do it. So we do lot of experiments. I hope it's clear how outliers are handled. Initially, we'll visualize a box plot, and if you are going to use any RRR technique, any one of the technique from RRR, 3R technique, we have to calculate the limits also. If you don't want to go with RRR technique, if you want to use Winsorization, you need not calculate limits. You can directly go and import the function. That is more than enough. That is enough. So this is what we do. Under handling outliers, outlier treatment. Now, Let us go to the next step, that is zero and near zero variance. What is this zero and near zero variance? Let us understand it. First of all, what is variance? Variance is nothing but the spread in the data. Okay. So, in short, do we have all the values same in the column, or do you observe any kind of variation, a spread in your values in the column? So, within the column, do you observe any kind of variation or not? If there is no variation, what is the use? So, we'll identify columns with zero and near zero variance, and such kind of columns will be dropped. Why should we drop zero and near zero variance columns? Because if the column does not contain any kind of variance, we cannot perform any kind of analysis. Nothing can be understood. Okay. So assume that there is a column, guys, like X, and all the values are 75. All the values are 75. So if I ask you what is the mean, the mean will be again 75. Yes. Sum of observations by number of observations, 75. Okay. As you see, there is no deviation, no spread from value to value. Such kind of columns are nothing but they don't have any variance in the column. There is no information. Those kind of columns have to be identified and they have to be dropped. Why? If you don't drop such kind of columns, they are not going to help us. Even in the further steps, they are not going to help us. So what is the use of having them in our data set? For that reason, we drop zero and near zero variance columns. I hope it's clear. Yes. So I'm importing the required packages first of all. So for me, pandas is enough for this zero and near zero variance. Pandas for data manipulation. And as we are working on the cars data, okay, after, I'm going to work on the cars data set, right? So I'm going to read the data set using read underscore Excel function. I'm going to use read underscore Excel function to read the data present in the Excel file. And the data will be stored to data frame DF. DF will be the data frame of size 428, 14. Next to it, what do you have? We have a print function which is going to print a message. Which is going to print a message. What will be the message? Data types of each column. This message gets printed. And we are also going to check the data types of each and every column. So we know that there is an attribute called dtypes. And this dtypes attribute will return the data types of all the columns present in the data frame. Let us have a look. See. So these are the data frames, the data types for all the columns. Now, in order to calculate variance of any column, we use the function called var, var. So df dot var function will return the variance of each and every column. So let me do it. And where are we going to store the results? The variance of each numeric column will be stored in variance variable. So it is a series, and here we have the variance calculated. You see, this is the variance of all the 9 columns. Why it is not calculating for non-numeric columns? Because variance is calculated on a formula. What is the formula? Summation of x minus mu whole square by n. Okay. So now I'm going to print a message. Okay. So where it prints variance of each numerical column to the console, and it is also going to print the variance values. Do you find any for any of the column the variance as 0 or near 0? Come on guys, do you find for any of the column the variance value as 0 or near 0? No, none of the column. None of these columns have the variance values close to 0 or 0. Don't assume they are close to 0. They are e power value, e power e plus 0.8 represents the value multiplied by 10 to the power 8. Okay. So for all the values, if you see, so this is 10 raised to the power 0 means what? 1. So here we see a value close to 0, but still it is not 0, right? And moreover, this is an important feature. There is some variance. It is not 0, there is a kind of variance. Even here also there I find variance. So there is no kind of column, no column can be removed. Okay, as each and every column has a variance value, there is a spread. Because of this, I'll not drop any of the columns. But still, what I'm going to do is, what am I going to do? What operator it is this guys? What operator is this? Comparison operator equals to. So, we are saying that is any of the variance value is equals to 0. We are comparing with 0. So, what will be the output of comparison operator? What will be the output of comparison operator? The output of a comparison operator will be a bool value, either true or false. So this will return me true or false. But I can clearly understand none of the value is 0, right? So all the values will be false. All the values for all the columns will be false. Clear? Yes. So that means we have also understood the concept of 0 and near 0 variance. 0 and near 0 variance. The next topic that we have is, the next step that we have is discretization or binning or grouping. Discretization or binning or grouping. What is discretization? Discretization is nothing but it's a process of transforming continuous data. If you have continuous data, this continuous data can be transformed to discrete data. Continuous data will be transformed to discrete data. That is what we do in discretization, binning, or grouping. First of all, what is continuous data? What is discrete data? Discrete data means fixed set of values, fixed data. Like examples, number of characters in your names. Will it be fixed or will it change? Fixed. Number of mobiles that you have. Number of cars that you own. So, if you take all these examples, that will be part of discrete data. But for continuous data, the data which is represented in decimal format, floating values, like weight of a person, height of a person, temperature, what will be the temperature tomorrow? So what kind of values you will have under continuous? Decimals. So the range of continuous data will be minus infinity to plus infinity. The range will be minus infinity to plus infinity, guys. So, in short, if you have continuous data, I can convert this continuous data to discrete data. How? By perform discretization or binning or grouping. Clear? Yes. So let me take an example. I'm going to import pandas, the required libraries, the packages as PD. Then I'm reading the same data. Anyhow, I have the data, but I want to read the data once more. And I'm going to save it in an object called data. I'm going to save the results in a variable called data. So let me do it, guys. It's done. Now, you see the size of the data where we have 428 rows and 14 columns. So it is nothing but the original data. So now taking this original data, I'm going to perform discretization. I'm going to perform binning. Right? Yes. So now to perform discretization or binning or grouping, we use a function called cut. We use a function called cut. And this cut function is from pandas package. PD represents pandas. So from pandas, we are using a function called cut. Okay. So let us understand how we are able to perform discretization. I'm going to perform discretization on the column engine size. On the column engine size. What kind of values you have in engine size? We know that engine size have float values. Nothing but decimal values. It's representing a continuous data. And this continuous data, I'm going to make it as bins. I'm going to start building bins. I'm defining the bins. The bin says it has to start from the minimum value of data.engine size. From this engine size column, in data frame, it will return the minimum value. From the minimum value, the bin gets start. Till where? Till the mean, the average, the mean of the data of the same engine size column. So this will be one bin. From min to average will be one bin. Then starting from average, the second bin will be till max of the value that is present in engine size, a maximum value. So how many bins you'll have? 1 and 2. So to these bins, I'm giving labels. Low bin, high bin. So this will be low and this will take high. What you are doing? You have continuous data, and this continuous data I'm going to convert as discrete data. By performing discretization, I'm going to convert this continuous data to discrete data. And where are these results getting stored? In the same data frame called data. The results will be stored in the new column called engine size underscore new. So that means a new column will be created to store the results. I hope it's clear. So let me execute all these lines of code together and let us compare the results. I'm going to do it. Done. Where are the results got stored? They have stored in data. Let me maximize it. So this is engine size column. And this is what? Engine size underscore new. So continuous data got converted to discrete data, fixed. Clear? So I'm going to order it. The lowest value and the highest value. Clear? Yes. So discrete data, continuous data got converted to discrete data, guys. But the challenge rises here. Let me get the value of each and every category. I want to get the categories. How many categories we have? Low category and high category are the two categories that we have in the column engine size underscore new. So let us get the count of it. In order to get the count of each and every category, we have value underscore counts as the function. We have value underscore counts. So this value underscore counts function will return the distinct categories and their count in the column. What are the distinct categories that we have? There are low and high category. There are only two categories. Right? So let me execute this line of code. Done? Yes. The low values are 219 and the high values are 217. Low, how many values we have? 219. And for high, we have 207. Add both of these. So this is 9 plus 7. It will be what? 16. 1 plus 1, 2. Okay, then 2 plus 2, 4. I'm getting only 426 days. But how many records are there? 428. There are actually 428 values and I'm getting the value underscore counts output as only 426. Why? Even this should match, right? When I pass 428, I should get 428 as output. So under the cut function, there is a parameter called include underscore lowest. Include underscore lowest. Yes. So include underscore lowest is a function that I'm using here. Okay. So what is the data that you are passing? I'm passing the same engine size column. We are passing the same engine size column. Okay. The same bins, min to mean, mean to max. But additionally, I'm specifying a parameter. What it is? Include underscore lowest. So that means to include the lowest value. By default, what happens is the lowest value will not be included, guys. So because of that, there are two values which are lowest values in the original column, engine size, and they are not getting included. If you make it as true, and if you rerun the code, and the results I'm going to store in engine size underscore new one, a new column, one more new column. You see here? Yes. In the earlier column, whatever we have created, without including the lowest, what happened? They were not included. The lowest value were not included. 1.3 was not included. But when you make it as true, it has included now. Now, even though if I go and calculate the value underscore counts on the new column, I'll get the count as is 221 plus 207, 200, 200, 400, 21 plus 7 is 28. So together it is 428. Clear? Is it clear, guys? Yes. Now, let me go to the one more case. Let me go with the same case where what we are doing here, try to understand the code. What are we doing there? I'm performing discretization using cut function, and which column is being used? Engine size. I'm using engine size column, and what are the bins that I'm going to have? How many bins will I have here? Just go through the code and let me know how many bins I'm going to have. What will be your response? See, I am going to have in total 4 bins. Min to Q1, Q1 to Q, that is nothing but mean, average. Mean to Q3, Q3 to max. So how many bins? 4 bins. 4 bins. So let me run the code. And the results, where are we storing? In a new column, engine size underscore multi. And what are the labels that we are passing? Small, medium, large, extra large. So 4 labels for 4 different bins. Done? Yes. So let me open the data set, the data frame. We should have the last column as engine size underscore multi. You'll find all the 4. And I'm going to return the value underscore counts of this particular output. The count of the cars in all these 4 different categories. Okay. So I'm going to return the value underscore counts for all these 4 categories. So together, if you see the 4 hundredths, 14 plus 7 is 21, 21 plus 4 will be 25, 25 plus 3 is 28. So 428 and 428. Done. So we have successfully completed discretization as well. Clear? So far, what are the topics that we have learned? Let us recap quickly. Typecasting by type conversion. Then next to it, handling duplicates to handle the duplicates in the data. Outlier analysis to handle the outliers. The extreme values. Zero and near zero variance. The features with zero and near zero variance will be dropped. And finally, we discussed discretization, binning or grouping, which means what? Converting continuous data to discrete data. Clear? Yes. So we'll continue with the next rest of the topics under data preprocessing in the coming session, the rest of the 4 topics. And now let us discuss about the free internship program that Nextera Unitech is providing. Yes. So what exactly you mean by, what you are going to learn as part of this internship? First of all, majority of us are not clear on the definition of internship. You should understand what is internship, and we'll also understand the phases that we are going to have in the internship that we are going to provide to you. And post completing, the first phase, you are supposed to work on a project. Okay. So you'll be working on a project as part of your internship, and you'll be also given with a certificate. Okay. So let us understand all these topics for next coming 10 to 15 minutes, guys. So concentrate, and whatever the questions that you have, all of them will be addressed at the last. Right. Yes. So first of all, Nextera Unitech. Nextera Unitech is, an edtech where we focus on comprehensive trainings. Apart from trainings, we also do real-time projects. Okay. So we do We do give trainings on data analytics, data science, artificial intelligence. Okay. Then Python topics like core and advanced Python. Okay. Even in the coming days, we are also going to launch sessions on IoT, embedded systems, and more. Our curriculum is designed based on, real world applications. Whatever the real world applications were being developed, accordingly, we have designed our curriculum. And we focus more on hands-on learning, guys. We focus more on hands-on learning. Okay. Whatever the topic we do, we deliver in the sessions. We also ensure that everyone is getting the practical exposure. When do they get practical exposure? When they do lot of hands-on practice. Apart from the trainings, we also provide industry recognized free internship programs. Free? Yes, it is completely free. Okay. So let us understand about what is an internship. First of all, you have to understand what is an internship, right? What do you mean by an internship? How do you define an internship? Internship means, it's nothing but you are getting a real world experience. You are going to gain real world experience, which will enhance your problem solving skills. Okay. So your problem solving skills can be enhanced and you get an opportunity to work on the projects. But the question raises, I'm not good at data analytics, or I am not clear on the concepts of data analytics or data science. But how can I work on a project? Still, we have designed our journey of the internship in such a way. It's a beautiful way which contains multiple phases. And moreover, you can also develop your network. Right? Yes. So as this is a free internship, guys, I want you guys to share across your connections because this is going to benefit majority of the students. Not only students, any one of you can be part of our free internship program. Okay. Even though if you're working, you can be part of the internship and you can gain skills. Initially, you'll be gaining the skills on the required topics and then you'll be gaining the real world experience by working on a project. So this is how we have defined our internship. Let us understand what are the phases that we have. What phases do we have in internship? Under our internship program, initially you will have an orientation session, probably on the next day of the demo. Okay. So on the orientation session, we'll be introducing you to the tools and whatever the expectations that we are expecting from you, the commitments and all. Everything will be detailedly explained in the orientation session. Okay. If you want to be part of the internship, ensure that you don't miss out to join this orientation session because everything we are going to discuss in this orientation session. So next to orientation session, immediately we'll start our learning phase where we'll be learning the concepts. We are going to learn the core concepts like Python, SQL, Power BI, okay, EDA, data preprocessing. So there are multiple core concepts. So all these core concepts we are going to learn. And across your learning phase, you will have a mentorship. Not only across the learning phase, you'll also have the mentorship during your project phase. Whatever you learn in your learning phase, those skills will be used in your project phase. So the benefit that you get from this internship is you will be working on a project, guys, and this project will be a group project where we'll be just discussing, we'll be sharing our ideas, how we can accomplish our project. To accomplish our project, we are going to share our ideas, but it will be a individual project only. It will be a individual project, but you guys will be doing it as a group. Why it is an individual project? If you do individually, only then you are going to learn. Whatever might be the case study that was provided to you from the industry standpoint, okay, you have to do research, and accordingly you have to collect the data, and then you are going to apply your skills on the project to accomplish it. So we share our ideas on daily basis by connecting here and there, and we'll try to complete our project. So this is how we have the internship phases. Orientation session followed by learning phase and finally project phase. Let us understand each and every session probably here. So if you see here, in learning phase, in the learning journey, what you are going to do? Learning phase will be for 30 days, guys, where you will be learning Python, EDA, data cleansing, SQL, and followed by Power BI. Even though if you are not from IT background, okay, if you are not from AI background, that's fine. Initially, you'll learn all these topics. You learn these topics and then you'll implement on a project. Okay, so project phase will be for how many days? Project phase will be for 15 days, where you'll get the support, but the mentors will not go and they'll not spoon feed you. No spoon feeding. They'll share the ideas, they'll give you support, but you are the one who is going to do the project. And additionally, from this batch, we have a small change in the assignment parts. So for this batch, on every day during the learning phase as well as project phase, on daily basis, we are going to connect with the team, with the batch mates for at least 30 minutes. And we are going to understand how well you are going to learn these topics in learning phase, and your project phase will be discussing our ideas. So that means on daily basis, the mentors and the batch mates, every one of us are going to connect, and we are going to sit and understand what we have learned on the day. Instead of doing assignments, this is a kind of cross-checking, guys. Okay, whether you are active in the internship or not, and moreover, you'll also be helped with the doubt clarification. If you have any doubts, you can address all your doubts. All your doubts will be addressed in these 30 minutes. At least half an hour. And it can go beyond it. So this will ensure quality training. Good training will happen if there is a kind of seriousness. Right? So that is the reason we have brought up this change from this particular batch. Okay. So what you are going to do is, on daily basis, we'll be posting the session links, and for each and every session, you are going to come up with, you will be forming our batchmates. Every one of us will go and they'll come up with multiple choice questions, then short answer questions, and if it is also eligible for any kind of coding questions, that particular session, you are going to frame the question and answers. Who is going to do all this? You people are going to do it. When you do all these things, you will learn. When you learn, you will do your project well. When you do your project well, you can showcase it in your resume. And when you have it in your resume, you can get a job immediately. See, everything is interlinked. And you know how there is a lot of demand for data related roles in the current market, right? So utilize this opportunity, guys. And how much are we going to charge from you? It's completely free, not even a single rupee. Not even a single rupee from your pocket you need to invest. No, everything will be free, and you'll also get a certification which is industry recognized. So these are the complete details of the internship, right? Yes. And finally, the certification. When it comes to the certification, you know, you'll receive a certificate upon the completion of your project. You'll receive an internship certification, and this is going to add a lot of credibility. So this will enhance your resume, obviously, right? And you can also add it to your profile, your LinkedIn profile. And this will ensure that it is going to showcase the experience. This will ensure that it is going to showcase the experience that you have worked on an internship. And finally, the career opportunities. There are a lot of opportunities, especially, related to data. So that is what I'm telling. A lot of demand. Why don't you be part of real time? But before you be part of real time, it's better if you have an internship experience. That experience, you can grab it here. This is going to make you job ready. Okay. We have related roles like data analyst, data scientist. So such kind of roles, okay, you can be ready, and you can also go through the different opportunities that we have, right? Yes. So are you ready to start your career? So don't miss out this opportunity, guys. This is one of the wonderful opportunity that Nextera Unitech is providing to you. Okay. So this will enhance your skills, and moreover, you're going to gain the experience. Okay. So be part of this program. Be part of this program, and moreover, you'll be completing your project, which is very important. Right. So in order to be part of the internship, the link has already been provided. Okay. So complete your registration. Once if you complete the registration, we'll be sending you the Google Classroom code. You can be part of the classroom. Okay. Right. That will be done on the orientation session day. So the message has been pinned. You can register for the internship program. The link has been provided in the chat and it has been pinned. Any questions related to the topic that we have discussed? Or you can also ask the questions related to internship. Any questions, guys? Others? Any other questions? Yes, if you have any questions, feel free to ask. Any questions? Right. I'm assuming no questions. And we are going to post the feedback link. Your valuable feedback before you leave. And before that, if you find that the session went well, hit on the like button and do subscribe to our channel, because we are going to come up with amazing content in the future. So consider subscribing our channel. And if you have any kind of questions, you can also use the comment section to post your queries, your questions. Right. Yes, hit on the like button, guys. It's a kind of support that you're going to give from your side. Yes, we also provide projects. That is what you can be part of the internship, so that you'll come to know each and every aspect that we are doing here. Yeah, we also provide major minor projects, okay, that you do as part of your graduation. Okay, so you can contact to the number that was provided in the link. In the registration link, we have provided the link, the number, right? So you can contact to the number. Any other questions? Yep. Thank you so much, guys, for joining and making the session interactive. So before you leave, hit on the like button. Okay, if you find that the session went well. Thank you so much, guys, for joining, and thanks for your compliments. Thanks for your feedback. Thank you so much. Have a great day.